Hi, my name is Chase McLeod, and so just a kind of quick background on everything. Immunosuppressive drugs are a class of pharmaceuticals that can be used to suppress the immune system's activity by targeting different pathways. These pathways and drugs are often used in individuals undergoing organ transplantation or with autoimmune and inflammatory diseases. So in this picture, I kind of have just on my left here, just kind of gave some examples of some more popular oral immunosuppressive drugs. So kind of just go down the list just real quickly. So you got tacrolimus, sirolimus, everolimus, mycophenolate, and then you can continue the list. Kind of shows about how the T cells and LGs play a part. So the next thing I want to get into is the immunosuppressant drug that I chose, and that is tacrolimus. And so, what tacrolimus is an immunosuppressive drug that is commonly used in the kidney transplant patients to prevent organ rejection. Tacrolimus is also known as FK506, and it belongs to the macrolide class of drugs. Tacrolimus is available in different formulations, including oral capsules and injectable solutions. So for this picture on my right, I was just kind of showing mainly how tacrolimus was used as resistant in SARS COVID-2. So as you see here, it was just an oral capsule that the person took. Kind of just shows the steps. So PNB isolation and SARS-CoV-2 specific activation. The isolation of SARS-CoV-2 reaction T cells kind of shows the diagram right there. Then the next step would be about how T cell expansion and CRISPR Cas9 mediated of FKB12. Then it will be infused of the tacrolimus resistant. And then this overall will improve cellular and humoral immune responses in SARS-CoV-2 infection. So I just thought that was pretty interesting knowing that about the pandemic we all recently went through. Next thing kind of just wanted to get into was talking about more of the pathways targeted by tacrolimus. So let me move my picture. Tacrolimus acts on a pathway called the calcineurin pathway. And so the calcineurin pathway plays an important role in the T cell activation and differentiation. So when it's activated, the calcineurin activates a transcription factor called NFAT, which promotes the production of cytokines and T cell activation. And so kind of just for this picture right here, it's kind of focusing more on about how the calcineurin pathways play an important role. And so I showed schematic of calcium or Ca2 plus, the regulation in a cell. Kind of just go along here, kind of see how everything starts playing a part. So you go at your SMLC, how the Ca2 breaks it up, go through your R11, how your Ca2 breaks that. It just kind of just shows them different activations and differentiations. The next thing I wanted to really get into was the mechanisms of the action. So tacrolimus binds to a protein called FKB12 inside the T cells. This tacrolimus FKBB12 BP12 complex then binds to the calcineurin and inhibits its activity. So after this inhibition prevents the activation of NFAT and subsequent cytokine production and T cell activation. So by blocking the calcineurin pathway, tacrolimus downregulates the immune system, which is necessary to prevent rejection of the transplanted kidney. So in this kind of picture, I just wanted to show the inhibition of FK506 inside of the cell. So you can see your T cell receptors, how that connects to your ER, then how your extracellular Ca2 is entered. Kind of just shows how they play their part. Also, how the FK506 enters and how it will connect to the FK BP12, which was just mentioned. So the downregulation of the immune system, inhibiting the calcineurin pathway with tacrolimus leads to downregulation of the immune system. This downregulation reduces the risk of the transplanted kidney being rejected by the recipient's immune system. However, downregulating the immune system can also lead to an increased risk of infections and other complications, which is a common side effect of immunosuppressive drugs. So, in conclusion, tacrolimus is an immunosuppressive drug that is commonly used in kidney transplant patients to prevent organ rejection. It also targets the calcineurin pathways in T cells, which is important for T cell activation and cytokine production. By inhibiting the calcineurin pathways, tacrolimus downregulates the immune system and reduces the risk of transplant rejection. But then, as we just stated again, downregulating the immune system can also increase the risk of infections and other complications. And so this for my last slide is kind of just show my references. Thank you all for listening.